All right, so last two sections we're going to take a look at in the course are 11.1 and 11.2. You might have done a little bit with this in Algebra 2. You don't do it in Algebra 1. But it's on sequences, and then 11.2 will be on what's called a series. So a sequence of numbers is basically just a list of numbers that has a pattern to it. Okay, there has to be a formula for how you're getting the numbers you're getting. Right. A sequence, it's always in a specific order. Okay? You can't just write the numbers in a sequence randomly, otherwise it wouldn't be a sequence. There's a pattern to it. Okay? Usually you name a sequence with just a letter. So we could call this sequence A, B, C, whatever you want to call it. And this particular sequence starts out with 1, 1/2, 1/3, 1/4. And the next one would be 1/5, 1/6. Basically, the denominator is going up by 1 each time. The way we reference like which term we're talking about is we use b with a subscript. So b sub 1 means the first term in sequence b. b sub 2 means the second term in sequence b. And then b sub n would represent the nth term. So a lot of times what we're going to want to do is figure out what's a formula to figure out the nth term. Especially if they want to know like the 300th term. You don't want to have to figure out every single term before that. Okay, we want a way to just jump to whatever term we want and find it. Right, so we'll talk about how to do that. Right, so this is kind of getting at what I just said. In order for a sequence to be unique, there has to be some rule or some kind of formula for calculating the terms of the sequence. Now, sometimes you can come up with more than one formula. A lot of times, if you come up with a different formula than someone else, but it gives you the same terms in a sequence, you could probably simplify your formula to the other person's somehow. It probably would be the same thing. Subsequences can be really hard to figure out. In general, most of the sequences we look at won't be. But some can be. They're really, really challenging. So let's look at this one. Does anybody see what the pattern is here? Yeah, I'm plussing 3. So if you think of it as plus 3, right? Basically, to get to the next term, you take the one before it and add 3. So you could basically write, this isn't the short way to write it, but I'm just kind of writing it out in words. Take the term before the one you want to know and add 3. Now, what's wrong with thinking of it that way? Like, let's say I want to know the 900th term.
Because then you don't know the number. You wouldn't know the one before it.
Right. Then you got to figure out the 899th term and just add 3. So that's easy, right? Well, now to get the 899th term, you need the 897th, 896, 895. You're going to need every single term. So another way to think of it would be, give me 1 second. All right, I got it. Think of it like that. So let's see what I kind of did there. So this is the first term, the second term, third term, fourth term. If you take 4 and triple it, what do you get? 12 minus 1? 11. If you take 3 and triple it, you get 9 minus 1 is 8. If you take 2 and triple it, 3 times 2 is 6. 6 minus 1 is 5. So what I did is I came up with a formula that, bless you, if you wanted to know the 500th term, it's 1499. It's 15, 3 times 500, take away 1. So I came up with a way to jump to any term that you want. Okay, and we'll talk more about how I figured that out. Okay. But any questions on that idea? This is kind of the goal. That's a better way to think about it. Thinking of it as the term before plus 3 is also correct. It's just not as easy to work with the one above. So some sequences have a start, an end, and that's it. Some sequences go on forever. So if you have a sequence that goes on forever, it's called an infinite sequence. Okay, so if I put that formula back up that I have, if this particular sequence that I have a red box around is infinite, then what that means is the domain of n can be any positive integer you want. You would never use decimals. Why? Because n represents a position in the sequence. So you can be at the first term, you can be at the second term, you can't be in between. There's nothing in between the first and the second term. Okay, there's no 1.3 term. All right. So n is never a decimal, and n is never negative, because there's no such thing as the negative 5th term in the sequence. We start with the first term, second, 3, 4, 5, 6, and so on. Right? So that could be any number that you want if this was an infinite sequence, any positive integer. Now, some sequences don't go on forever. Some have a stopping point. Right? That's called a finite sequence. So what that means is if you have a formula, like the one I have in red, that's generating the sequence, there's an upper limit to n. Maybe your last term is the 100th term. So the highest number you could plug in for n is 100. Okay? You can't plug in 101 because this particular sequence, if it's finite, doesn't have 101 terms. It stops at 100. So any question about the difference between an infinite sequence and a finite sequence? So a finite sequence has a fixed positive integer that represents the highest term in the sequence. Okay. So for today, basically the goal is to look at a sequence, try to figure out a pattern. Tomorrow, we're going to look at adding up all the numbers in a sequence. Okay. Especially in that kind of sequence. So you might be thinking, well, wait, how can you add up an infinite amount of numbers? Like if you got a sequence that goes on forever, how do you add up every single number? You can do it. Especially in the one that I gave you right here. Because if you look at that sequence, what's happening to the number each time? It's getting smaller. So by the time you get out to like the millionth term, it's 1/1,000,000th. It's so small that eventually you can almost think of it, it doesn't even make a difference anymore. Right? In this sequence, because the terms are getting smaller. Now, if you had a sequence where the terms are getting bigger each time, that's kind of a problem. But if they're getting smaller each time, we can work with that. Okay, and this, I think this sequence would add up to 2. If you added up every number from 1 to infinity in this sequence, it would never go over 2. Because the first one is 1.5, then 1 3/4, then 1.5 plus 1/3, then plus a quarter. No, I lied to you. It goes over 2. I'd have to double check it, but it doesn't go over something. Okay, but I think it does go over 2. Okay, but it won't go up forever. Okay, so here's a formula that they gave us. And what we're going to do is just practice listing out the first 3 terms and the 15th term. Now, if you look at the formula, the way they wrote it is they didn't say to take the term before it and add 3. Okay? What they did is they gave you a nice formula that you can find any term you want directly. So to find the 15th term, I don't need the 14th term, and the 13th, and the 12th. I can find just the 15th. So what you do to find a specific term is you fill n in with the term you want to know. So if you want to know the first term, let n equal 1. Okay, so we'll start with that. By the way, if I plug 1 into the top, what's 1 squared? 1 and then minus 1. So I'm left with 0 divided by 1. And Casey, 0 divided by 1 gives me 0. Okay. So the first term of this sequence is 0. Second term, I plug in 2. Caitlin, what's 2 squared?
4.
Minus 1? 3 over 2. So the second term of this sequence is 3 over 2, or 1.5. Ezekiel, how about my third term? What's 3 squared?
9.
Minus 1? 8 divided by 3. So my second term is 8/3. If you notice here, the numbers aren't getting smaller each time. They're getting bigger. Okay? So the first one was 0. The next one was 1.5. The next one was 8/3, which is what? 2 2/3. So they're getting bigger. Okay, let's look at a sub 15. 15, how much is 15 squared? 225 minus 1 gives me 224 divided by 15. Let's see what that comes out to. 224 divided by 15. 14.9. Okay? And what number did I plug in for n? 15. So we can see what's happening here is the answer that you get is getting closer and closer to that number.
But it won't ever be that.
It won't ever quite be that number. It'll get very close. Like this one was 14.9. If we did, we didn't do 10, but we could do 10. 10 squared is 100. Minus 1 is 99. And then 99 divided by 10. 9.9. We plugged in 10. Okay, so it's getting very close. So, any questions on how to do that? All right, let's try this one. So this says -1 to the n times 2 to the n. What happens when you raise a negative number to a power? Actually, two things that could happen. Depends on what the power is.
From positive?
It could become positive if the power.
It's odd, negative.
If it's odd, it's negative.
Odd, if it's even, it's positive.
And if it's even, it's positive. So what's going to happen here is we're going to get an alternating positive-negative sequence. Okay? If one term's negative, the next one's positive. The next one's negative, the next one's positive. But 2 to the n is also going to cause it to get bigger. It's not just going to be -1, +1, -1, +1. So let's see what happens. All right, Brandon, what's -1 to the first power? And then 2 to the first?
2.
So 2. So the first term in this sequence is -2. Now let's look at the second term. Michael, what's -1 squared? 1. And what's 2 squared? 4. So what's going to happen each time is it's going to double, but it's going to change sign. All right? So what would the third term be? It would be -8. -1 cubed times 2 cubed. And now for the 15th term, I can kind of figure it out. We'll look at the odds. The odds are negative. So I know the answer is negative something. So that That takes care of negative 1 to the 15th. Now I need 2 to the 15th. So 2 to the 15th. Oops. 2 raised to the 15th. Okay, so we get 32,768. This is another sequence that's just getting bigger and bigger and bigger. So this is not the kind of sequence that you could add up all. If there were an infinite amount of terms in the sequence, if it went on forever, you could not add them up. They wouldn't add up because it just gets bigger and bigger and bigger each time. Okay. Questions on that? Next one. So the kind of formulas that I gave you, okay, I didn't name them earlier, but what they're called is an explicit formula. Okay. That's an explicit formula. That's an explicit formula. Let's see. That's an explicit formula. That one is not. That's saying do something to the term before and add 3. What's nice about an explicit formula is it allows you to find any term you want directly without having to find anything else. Versus a recursive formula. A lot of times recursive formulas are more obvious to us. You see a pattern and you're like, oh, it's just the one before it plus 3. But if you want to find the 1,000th term, then you would have to know the one before it and then add 3, and the one before that and add 3. Okay, so in a recursive formula, what they'll generally do is they have to start you off with the first term, or maybe the first couple. Because if I said to you, here's the pattern, take the term before and add 2. Well, you have to know where to start from. So now if I said, okay, start at 0. Now you can do it. Take the term before it and add 2. So there's your next one. Take the term before it and add 2. There's your third one. Okay, but they got to give you a starting point. This would be exactly the same formula. It's just the term before it plus 2. The only difference is the start point. Okay? So these two would have the same recursive formula, but a different starting point. Okay, so recursive formula, first couple terms are usually given. And the nth term is defined using previous terms. Sometimes it's the one before it. Sometimes it's 2 before it. Okay? I'll show you a sequence in a little bit that doesn't just use the term before it to find the next one. It uses 2 before it to find them. Okay, and we also need some kind of notation. We don't want to write term before. Okay, so I'm going to show you how we do it. Let's say that's the term we're at right now. If you want to know the term after it, that's this one. Okay? If n is your term, the next one is n plus 1. So let's say you were at the 5th term. The next term is the 5 plus 1. It's the 6th term. So using that idea, anyone think they could tell me what the one before n would be? A sub n minus 1. So if you're at the 5th term, the one before it would be the 5 minus 1 term, or the 4th term. That is how you write the term before. A sub n minus 1. Just means back up one term. How about if you wanted to back up 2 terms? How would you write that? A sub n minus 2 would mean 2 before where I am right now. Okay, so here's here's a recursive formula. They're telling me the first term is 2. Okay, they got to tell you where to start. And now, that's the formula to get to the next term. What this basically says is, to get to a term, take 3 plus the term before the one you have now. That's what the minus 1 means. So, if you wanted to find the second term, just plug a 2 in for n. And that'll kind of spell out how to do it. So a sub 2 is 3 plus a sub 2 minus 1. 2 minus 1 is 1. So to find the second term, do 3 plus the first term. Well, what's the first term? The first term is 2. So to find the second term, it's 3 plus 2, which is 5. Okay. Now, if you wanted to find the third term, plug in a 3 in both of those spots. So a sub 3 would be 3 plus a sub 3 minus 2. 3 minus 2 is 2. So now to find the third term, it's 3 plus the second term. Well, I just got the second term in the last step. It was 5. Okay, so in this formula, my third term would be, 8. Okay, so that's how you do it recursively. Now, let's say you wanted the 200th term. Besides the fact it's going to take a long time, what could happen as you're trying to get to the 200th term?
Mess up.
You mess up. Okay? And unfortunately, if you mess up in one spot, everything's messed up. Okay? Everything's messed up. So recursive formulas, not the best way to do it. But if you were to give me this sequence, 2, 5, 8, I could look for a pattern and try to change that into an explicit formula, which would be much better. All right, so let's look at this. They want us to find the first 4 terms and the 8th term. And have they given me an explicit formula or a recursive? Yeah, because it says to do something to the term before it. Okay, so this means to find the 8th term, even though they didn't ask for the 7th, the 6th, and the 5th, we have to find them. Okay. So what I did is I just kind of made a little chart. They always have to tell you where to start. So the first term is 2. How about Wyatt? What's my next term going to be?
6.
Yep. So to find the second term, take 4 plus the one before it. Well, the one before it is 2. Plus 4 gives me 6. Hannah, how about my third term?
10.
10. And my fourth term is 14. So now we've determined the first 4 terms, but we want to get all the way to the 8th term. So we gotta keep going. Mina, my 5th term?
18.
18. Yep. Braden, my 6th term?
27.
22. Again, we don't really want any of these. We're just trying to get what they really want. Josh, my 7th term?
26.
26. And finally, I can get to the 8th term, which is 30. Not too bad to go to the 8th term. But if you wanted to go to the 800th term, we got to get a better system. Yeah, you're just adding 4 every time. So maybe you could just do multiplication, like, oh, to get to the 800th term, I added 4 800 times, so it's like I'm just adding 8 times 4, 3,200. But again, that's kind of the shortcut that we're going to figure out in a little bit. All right. So now they're giving us a recursive sequence. And we're going to see if we can convert it to an explicit formula. Okay. To do that, first thing you want to do is use what they gave you and write out the first 4 or 5 terms so you can look for a pattern. Okay. So what I'll do is I'll write out the first 3. Let's even go one more. First 4 terms. Okay. First term is given. Now, the formula says take 5 plus the term before to get the one you want to know. I want to know the second one. So 3 plus 5 gives me 8. Andrew, what would my third term be?
Coming up for 13.
13. And the fourth term would be 18. All right, so now to find an explicit formula, what you want to focus on is the position and something you can do with that to get a 3. So the number in the first position is a 3. So think of a calculation you can do with a 1 to get a 3. Like, oh, 1 times 3. All right, let's try it with the next one. The second one is in the second position. 2 times 3? No, that didn't work. So it's not times 3. Something you can do with a 3 to get a 13, and something you can do with a 4 to get an 18. I'm going to show you a formula for how to do this in a little bit, but does anybody see what you can do with the number I circled to get the number on the right?
Times 5 minus 2?
Yes, it's times 5 minus 2. So to find the nth term, take the one number you're looking for, times it by 5 and minus 2. Let's check it. 4 times 5 is 20, minus 2 is 18. 3 times 5 is 15, minus 2 is 13. 2 times 5 is 10, minus 2 is 8. Works perfect. Now, in general, that can be a very hard thing to do. Okay, that's not a complicated pattern, just times 5 minus 2. But imagine a pattern that was like, times it by 5, cube it, divide it by 2, square it, add 6, and then divide by 9. I mean, you're never going to figure out something like that by hand. So calculators can kind of help us a little bit with the pattern. But you're not going to get any that are, you're even going to need a calculator. Any questions on that? And kind of a hint is the 5 right here. Whatever number you're adding over and over, that, think of it, if you add the same thing over and over, right? That's like multiplication. If you do 6 plus 6 plus 6 plus 6 plus 6, that's multiplication. So that's kind of a hint at you're going to do times 5. Okay. And then the rest of it, I'll show you how to do after. All right. So I told you that some recursive sequences don't just depend on the term before it. They use 2 terms before it. So one example of that is called the Fibonacci sequence. Since this particular sequence requires 2 terms in a row before the one you want to know, I have to start you off with the first 2 terms. So to find the third term, you're going to use the term before it, the second term, and the term before that, the first term. Somehow, you're going to combine them in some way. And that's how you combine them. You just add them. So if you wanted to write this out for the third term, I'm not going to write it out for all of them, but we'll just do the first couple. The third term is going to be 3 minus 1 is 2. 3 minus 2 is 1. So to get the third term, add the second and the first. Okay, so what would the third term be here? 2. And how about the one after that? Three. And the next one? 5. And I think we need one more. Yep, 8. That's the Fibonacci sequence. This is an extremely hard sequence to convert to an explicit formula. It can be done, but it's a college level kind of problem. All right, so we won't even look at that.
So the entire thing Fibonacci is just take the past 2 numbers and
Yeah, you take the previous 2 numbers and add them together. Yep. This kind of sequence falls into a bigger category of sequences called a Lucas sequence. The Fibonacci one is the particular Lucas sequence that starts 1, 1. But you can start a Lucas sequence like this, 6, 7. And then if it's a Lucas sequence, the next number is the sum of the 2 before it. 13, 20, 33, and so on. Okay, some people do well with patterns because it's a very different kind of thing this year than we've done before. Some people don't like patterns, but it just depends on how you see things, I guess. All right, so 2 main kinds of sequences we look at are what's called arithmetic and geometric. Basically, what happens in an arithmetic sequence is to get from one term to the next, you add. You add the same number over and over. And that's how you would write it recursively. To get a specific term, take the one before it and add a number. Okay, we looked at a sequence like that earlier, where we added 3 each time. Okay. And the number that you add each time is called the common difference of the sequence. Okay. And if you're thinking, well, wait, you're adding a number each time, why do you call it a difference? I'll show you. There's a sequence where I add 3 each time. All right, so let's look at that. What's 17 minus 14? 3. 14 minus 11? 3. 11 minus 8? 3. 8 minus 5? 3. So the point is, if you have an arithmetic sequence, if you take a term and subtract the one before it, you will always get the same difference. That's why it's called a common difference. So in this case, it's 3. Now, if I had a sequence like this, hopefully you can see a pattern to it. That's not an arithmetic sequence. 32 minus 16 is not the same as 16 minus 8. Which is not the same as 8 minus 4. That's the kind of sequence we're going to look at next. Okay, so any questions on that? Arithmetic sequence has a common difference. Now, I'm going to show you the formula for how to change a recursive formula to explicit without guessing. Okay, so here, where was it? Here? No, the one before it. This one. So Hannah gave us this formula 5n minus 2. How she figured that out, I have no idea. Maybe she's just good with patterns and she's like, oh, it just times 5 minus 2. Well, now I'm going to show you how to get that, without just trying to guess what it is. So to find an explicit formula, first thing you have to do is take the first term plus n minus 1 times d. And remember, n has to be a positive integer, because n represents a position in a sequence. There's no such thing as negative position, and there's no such thing as a decimal position. So what I want to do is I want to take that formula, go back to the problem we just had, and kind of apply it and see how it works. So a sub n equals the first term plus n minus 1 d. So let's go back. What was my first term in that sequence? 3. So a sub n equals the first term plus n minus 1 times d. What's my, well, let's just check. What's 18 minus 13? 5. 13 minus 8? 5. 8 minus 3? 5. So the common difference is 5. Now, if you look at what I just wrote and what we were given up above, they don't look the same. But multiply the 5 out, you get 3 plus 5n minus 5. And what's 3 minus 5? There's your negative 2 right there. So that gives you a procedure you can follow to find the pattern without trying to guess it. Okay? Now, the downside is it only works for that type of sequence. There's millions of other kinds of sequences besides this one. But arithmetic comes up a lot, so that's why we've got a formula for it. Okay, so let's try this one. So find an explicit formula for that. So you're going to be using this. So you're going to figure out the first term and the common difference. You don't plug in for the n. Just the first term and the common difference. Now, what's wrong with that? If that's all they gave you. It doesn't give you the starting point. So now this says take the one before it and add 3. Well, where do I start from? All right. So we need a starting point. So I could just, actually we already did 5. Let's do something different. Let's do 6. So the first term is 6. And if you need to write out a few terms to see the common difference, you can. But you should be able to tell what you're doing each time. So what's the common difference here? 3. Because the next term would be 9, then 12, then 15. So if you subtract 2 terms, you're going to get a difference of 3. So what I like to do is let's just write out a few. So then once we have a formula, we can test it and see if it works. So 6, 9, 12. All right. So now let's fill in what's up above. Josie, what's my first term? 6. Yep. Plus n minus 1 times, Evan, what's my common difference here? 3. Because we're adding 3 each time. Now, at this step, you should do this out. So we'll FOIL this out. So we get 6 plus 3n minus 3, which is 3n minus 3. So the pattern here should be triple the whatever term you want, triple that position, and then add 3. Or subtract 3. Sorry.
So is it always the difference times the number minus the difference? Because that's how it was with the last one before. You know how it's just
Yeah.
like,
Plus 3, thank you. Are these two numbers always the same?
yeah, like the problem that we did before that, it was the same setup as that one.
It'll look similar, but they don't always have to be the same number. So we had a 3 and a 3 there. Here we had, was it a 5 and a 2 or something like that?
Yeah.
Yeah, so they might Yeah, they might be a little different. They can be different numbers.
But you could just look for the difference and then use the number in the first equation.
Yeah, you just look for the difference.
That's all you really need.
That's that right there. And then just look for that number, and that goes right there. Yep. All right.
That's only for
Arithmetic.
arithmetic.
Yep, only for arithmetic. So let's check our formula. Where are we? There we go. All right, so triple and add 3. If we triple, let's start with the second term. If we triple 2, what do we get? 6 plus 3 gives me 9. Perfect. Let's check, let's do one more. That should be 15. So if we triple 4, we get 12. 12 plus 3, 15. So that formula works perfect. Okay. Any questions on that? All right. So let's see. This says the first 2 terms in an arithmetic sequence are -8, -2. Find the 5th term. So terms themselves can be negatives. They can even be fractions. But the position is never a negative fraction. -8 is position 1. -2 is position 2. 3, 4, and 5. Now, if you didn't tell me that this was arithmetic and all you did was give me the first 2 terms, I could get multiple answers. Because I could say, oh, to get from -8 to -2, you divide by 4 each time. Okay? But I know it can't be dividing by 4 each time because this is arithmetic. So that means we have to add something each time. Or add a negative would be like subtracting. Okay. What am I adding each time here? I'm adding 6. So what would the third term be? 4. And the next one? 10. And the 5th one? 16. Not too bad to just do that real quick by hand. If you had asked me for the 500th term, what I probably would have done is found the formula and then plugged in. Because I'm not going to add 6 500 times. Okay, I'm just going to use the formula and make that a little faster. So, 16. Any questions on it? All right. Let's look at this one. This one says, find a formula for the sequence. Now, they've given us the 3rd term and the 8th term. But what term do you really need to do this? You got to have the first term. Okay? You need the first term, and you need the common difference. Well, if it's arithmetic, we know that we're adding or subtracting, adding a negative, same thing. The same thing over and over. So let's look at the difference between 13 and 3. What's the difference between 13 and 3? It's a difference of 10. So you're going down 10 units over 1, 2, 3, 4, 5 spaces. So you have to do the same thing every time. So now you're going down by 2s, but now you can reverse that to figure out the first term. So go up by 2. 15, 17. That's how you figure out your first term. All right, so we got the first term. What's my common difference here?
2.
Well, remember, to find the common difference, take a term and subtract the one before it. -2.
Oh, yeah.
Okay, if you have a sequence that's going down, that's a negative. All right. So be careful when you plug in, because that number is now going to be a negative. Okay, and when you distribute it, you're going to have a negative times a negative. Okay, so let's do that. So we've got nth term is the first term plus n minus 1, and what was my common difference? Oh, count. Yeah, negative 2. Okay, so distribute that out. So you're going to get 17. And actually, what are you going to get when you distribute out
Negative 3.
negative?
No, that's wrong. I'm sorry.
You are going to get a negative.
Negative 2n plus minus 1 plus 2.
Plus 2,
Oh, because you're multiplying.
because you're multiplying. So your final answer here would be negative 2n plus 90. So the formula should be to find a term in a specific spot, double the spot, and then add 19. So let's try the fifth one. What's negative 2 times 5? Negative 10 plus 19? 9. Perfect. Okay, usually I check it in a couple spots, but that seems pretty good. Okay, any question on that? So, another kind of sequence. Another name for a sequence is also called a progression. Progression sequence, you can use either word. Very similar to arithmetic, except you change one thing. Instead of adding the same number repeatedly, you multiply the same number. So when I showed you guys the sequence earlier, that's a geometric progression. Okay? In that case, it's doubling each time. Okay, so this type of sequence, to get any term, take the previous term and you multiply it by a constant. Now, these kind of sequences don't just have to grow forever. You could do the reverse. 20, 10, 5, 2.5. This one is getting smaller and smaller. I'm multiplying by 1/2 each time. Okay? And that's the kind of sequence where you can add up, say it went on forever. Eventually, the number you're adding is so small, right? Because you're taking half of half of a half of a half. It becomes so small, it doesn't even make a difference. Okay? So your recursive formula looks like this. To find a specific term, take the term before and multiply by a number. Okay. We don't have a common difference when we do this. Common difference is arithmetic. We have a common ratio. And the common ratio is the term after divided by the term before. Same idea as the difference. So let's say this was my sequence. And if you can't figure out, you're like, I'm not really sure what he's doing each time. Take a term and divide by the one before it. 24 divided by 12, 2. 12 divided by 6, 2. 6 divided by 3, 2. All right. So my common ratio in that problem is 2. Any question on that? Make sure you get that order right. Term after divided by term before. Because if you do it the wrong way, 3 divided by 6, you might think, oh, it's a half. Well, no, if you were multiplying by a half each time, the numbers would be getting smaller. But they're getting bigger. So here's the explicit formula for a geometric sequence. So it's going to kind of take the guesswork out of, if I give you something like that, how do you write a formula for it? Okay. You need to know 2 things. What's the first term? What's the common ratio? And that's it. It's kind of like arithmetic, where you need to know two things. Okay. That n minus 1, that's an exponent, just to be clear about that.
Will you go back over that common ratio example you just did?
The common ratio? Yeah. So in this particular sequence, to find the common ratio, take a particular term and divide by the one before. So like, let's say, for example, n was 4. One way to find the common ratio, if n is 4, 4 plus 1 is 5. And I plugged in n for 4. So take the 5th term and divide by the 4th term. 1, 2, 3, 4, 5. The 5th term is 48. The 4th term is 24. Divide them, you get 2. But you can pick any 2 you want. If they all come out the same, which they should, then you know you have a geometric sequence. Now, if somebody did something like this, either they made a mistake, or this is an extremely tricky problem to figure out. So chances are, though, if you do the same thing 5 times in a row, and then all of a sudden it switched, it's probably a mistake. If you see something like that, you could probably figure out a pattern for it. But with so few numbers, you guys might be able to figure out different patterns. Somebody may say, oh, take the term before it, double it, and add 1. I didn't even think of that. I was just writing random numbers, but that's actually what I wrote. Double 3, you get 6. Add 1, you get 7. Double 7, you get 14. Add 1, you get 15. But there might be other patterns besides that. Once you start writing down like 6, 7, 8, 9 terms in a sequence, there's probably only one formula for it. Okay? But with only 3, you could probably come up with different ways to do the same thing. All right, so let's look at this one. It says find an explicit formula for the geometric sequence. It's geometric. Okay, what would the 4th term be here, just based on these 2? How much? Well, first of all, what are you doing each time? Are you adding or multiplying?
Times a negative 2.
You're timesing, right? Because it's geometric. So if it's geometric, you have to multiply to get from one term to the next. So it doubled, but then it changed sign. So negative 24, positive 48, and so on, negative 96. Now it's good we've got the 6th term, but I really need the 1st term. So work backwards and figure that one out. What's the 1st term? 3, yep. So now we know the 1st term is 3. And to find the common ratio, take any term you want and divide by the one before it. So what's the common ratio?
3.
Negative 2. 12 divided by negative 6, or negative 6 divided by 3. Okay, no matter which way you do it, just take a term, divide by the one before it. That's your common ratio. Okay, so now look at your formula. It's the 1st term times r to the n minus 1. So my 1st term times my common ratio to the n minus 1. Let's check it for the 4th term, okay, and see if we get negative 24. So let's plug 4 in for n. What's 4 minus 1? 3. What's negative 2 to the 3rd power? Negative 2 times negative 2 times negative 2. Negative 8. And what's negative 8 times 3? Negative 24. That's exactly what we should have gotten. So now if I asked you for the 657th term, you don't have to multiply by -6 every time. You just plug in 657 for n and do it out, and you're done. Okay. Any questions on that? Okay, so that's sequences. So tomorrow we'll take a look at putting a plus sign between these and how can we find formulas to quickly add up all the numbers in a sequence. If a sequence only had 5 or 10 numbers, it's pretty easy to add it up by hand. What if a sequence had 20 million numbers? We can do it, but we don't want to do it by hand. There's got to be a faster way. And I'll show you that tomorrow. All right, so homework is all odds except for 14. So 1 through 5 odd, 9 through 13 odd, 14, 17 to 27 odd, and 31. So we'll take a look at that tomorrow. Tomorrow we start our last section for the class, 11.2. That'll be the next 2 days. And then our test this week is on Thursday.